Alright, so this will be the first video. I'm going to teach you how to find a parametric differentiation. In the previous video, I have introduced you that x and y can relate by using t, right? The parameter, right? So, or if you can using this t to relate x, y, become a Cartesian equation, right? Become a Cartesian in terms of x and y. So this is parametric equation. Right? If without the t you relate x and y, is called Cartesian equation. So now, for these cases, I want to use parametric differentiation. As you know that parametric differentiation, we can using chain rule, right? As you know that, now you know that y and x are relate to a parameter, right? T, a parameter. So now, so I have to relate my dy dx with the parameter, so which is dy dt multiplied with dt dx. It's a chain rule. As you see that if you cancel out the dt, you are getting dy dx, right? So now I'm going to apply this formula to finding the dy dx. So of course in this formula we have dy dt dt dx. So never mind, we're just finding the dx dt, differentiate, so dx dt. So differentiate t to the power of 2. So you know that is 2t. Differentiate constant, you have 0, right? So, and again, you differentiate dy dt. Differentiate 2t, you are getting a constant, right? You are getting a constant. So this will be your dy dt, and this is your dx dt. So I'm going to find the dy dx here. So your dy dx, is dy dt 2. Right? Dy dt, dt dx, dt dx. Your dx dt is 2t, right? Is 2t. So if dt dx, this whole thing will be reversed, right? 2t over 1, right? So dx dt now is dt dx, so 1 over 2t, right? So dy dx is dy dt multiplied with dt dx, which is 1 over 2t. Finally, you have 1 over t, right? So means that in this case, your dy dx is 1 over t, right? It's 1 over t. So in the same video also, I'm going to teach you how to find the second order differentiation of by using parametric differentiation. So means that we apply the chain rule again, means that the d dx of the dy dx. So means we find the second order differentiation. So d2y dx2 and d dx of the dy dx, right? D dx of the dy dx means I'm going to apply the chain rule again for this whole thing here. So it means that the d dx, dy dx, dy dx become my y, new y, right? So multiply with d dt is d dt, apply the chain rule again. D dx is d dt multiplied with dt over dx. As you see that, if I close the d dt, you will find out that this will be d dx, right? D dx, dy dx, right? Apply the chain rule again. So d dt dt. So then therefore this is the formula, right? So I conclude that d2y dx2, the most important thing is you must know this formula. Secondly, you must know that this is, you apply the chain rule again. It's the same. So d dt, just the y here you replace with dy dx multiply with dt over dx. So you have one and second formula here. So now the most important is you must know how to apply the formula of finding the second order differentiation. So now I want to find the second order differentiation. So you know that your d2y dx2 is the same as d dt, d dt, dy dx, d dt, dy dx. So your dy dx in term of t, 1 over t, right? So you're putting your dy dx into this formula and multiply with dt dx. Dt dx you can getting from here, right? Dx dt is 2t over 1, so dt dx is 1 over 2t. So 1 over 2t. So of course, this is the one that you should differentiate, right? d dt of 1 over t. So let's differentiate d dt. 1 over t is t to the power of negative 1, right? Differentiate t to the power of negative 1 is negative t, bring down the power, basic rule, t, and the negative 1, you minus 1, you're getting negative 2. Then you have negative 1 over t to the power of 2, right? So therefore, yeah, d2y dx2 is the same as negative 1 over t squared, right? So this one multiply with 1 over 2t. So finally you have negative 1 over 2t cubed. So this is the answer for d2y dx2. So in this video, I'm going to give you two examples. The first one, I teach you how to apply these two formula. Okay, the first one is for dy dx, the second one is for d2y dx2. Alright, so let's go for another examples. Alright, let's continue with these examples. So this is the parametric equation that x and y relate by t. But for this time, the x is in term of ln t and y is the exponent of t. Right? So means they are still related by the parameter here. Right? The t is the parameter, the third variable here. So means that they are related indirectly. So for this type of differentiation, we want to find dy dx, we need to apply the chain rule, right? Okay, I rewrite the chain rule, which is your dy dx. Dy dx is d over dt. For the y, right, multiply with dt over dx, right? Dy dt. Okay, so second, if you want to find the second order, means that you d dx, d2y dx2 of the dy, right? So apply the chain rule again. So d dt. Now just now is y, right? That's why here you have y, right? So but now it's d2y dx2. d2y dx2 is d dx dy dx, right? This is y, d dx, this is y. So this is d dx, this is dy dx. That's why you're going to replace the y with dy dx. This is how I understand the chain rule. So d over dt over dx, right? So I apply the chain rule again. So as long as a student, you must know how to using this formula here. Alright, this is a very important formula for parametric differentiation. So now I'm going to apply by using this parametric equation. So of course I need to find the dx dt. Differentiate ln. You must at first remember the formula for differentiating ln, right? Differentiate ln t, you know, 1 over t. Differentiate exponent t, et, salin balik, right? Differentiate t, you're getting 1. So you have know your dy dt, your dx dt. So you want to find dy dx. So we apply the first formula. It's actually a chain rule. So it's dy dt multiply with dt dx. So as you see that if I close these two, you see that I am getting dy dx, right? So dy dt et multiply with dt dx, right? So you know that dt dx, this is dx dt, so it's 1 over t. So for dt dx, it will be t over 1, right? So you're getting t, so means you multiply with t. So based on this result here, your dy dx, you are getting t e t. This is your dy dx. So now I'm going to using my dy dx to finding the second order differentiation of parametric differentiation. So second order differentiation for y. So second derivative for y. So the formula will be d2y dx2 equals to d dt, not dx, is d dt, right? dy dx multiply with your dy dx more dt dx, right? dt dx. Dt dx. So now, what is this? This is your dy dx. Where you get the dy dx from here, right? Dy dx in term of t. So it will be t e t. So this is your dy dx, right? D dt, dy dx, dt dx. Okay. So now you know that. Look at this. Look at this particular thing here, right? Look at this. What rule you going to apply for this? T e power of t. So very clear, is a linear function product is a multiply with an exponential function. So I'm going to apply a product rule here. Your product rule here, your u v, right? As you know that the product rule, the formula dy dx equals to u v prime plus with v u prime, right? U v prime plus v u prime. So I'm going to differentiate this directly because this is basics. So u, right? U is t. V prime, differentiate exponent. So you're getting et plus v is et. Differentiate u prime, differentiate t. You will have 1, right? Then you have differentiate. So multiply with dt dx. Don't forget to multiply dt dx. dx dt is 1 over t. So dt dx is t over 1, right? So multiply with a t, right? T over 1. So finally your d2y dx2. So you were getting t square et, or you can just factorize, right? Or you can just factorize the t out here. You put the t here in front here. So et and et you taken out, right? You taken out. So you will still have t plus 1, right? So you have t, the et common factor I taken out. So I have t plus 1. So this is also your answer. So this is the way. The most important is you must know how to apply the differentiation, how to do the parametric differentiation by using this formula or applying chain rule. So we go for more example in the next video.